Hello students, this is Professor Chalai, and in this video we're going to look at concentration, molarity, and dilution. By the end of this video, you should be able to describe what the molarity of a substance, a solution is, and you should be able to perform dilution calculations. Now, what is molarity? Let's look at an example. Let's say you have an amount of, let's say a spoonful of salt solution, salt, NaCl, and you dissolve it to create a solution. You dissolve it in 1 cup of water. And let's compare that to the same 1 spoonful of salt, NaCl, but now you've dissolved it in, let's say, 1 bucket of water. If you were to taste these different solutions, they would taste very differently, right? You might expect the cup solution would be saltier than the bucket solution. Well, they're both NaCl solutions, so why do they taste differently? Well, the answer is concentration. They have different concentrations. So what you should be gathering by now is that there are 2 aspects to determining what the concentration of a solution is. One is the amount of salt that we added in this case. We'll call that the solute. And the second is the amount of solvent. The amount of solvent. The amount of water. So those 2 aspects are important to calculate in the concentration. And the way we go about expressing concentration is using the unit of measurement we call molarity. Molarity. Sometimes using the symbol big M. So big M is molarity, and it's an expression of the amount of solute, usually in number of moles, divided by the amount of solution. That's a solute plus a solvent, usually in liters. So sometimes the units could be in molarity of big M or moles over liter. Those 2 units are the same thing, molarity and moles over liters. So if you know the amount of mole of a solute that you added, you know the total volume of the solution in liters, you can calculate the molarity. Okay, let's look at some dilution situations. So let's say you have a vial of some solution, and you take an amount of solution. Let's say you take 2.5 mils of this solution and you add it to a second vial, right? So you take that 2.5 mil, you add it to a second vial, and then you dilute it using additional water up to a new mark of 10.0 mil. You knew the initial concentration. Let's say the initial concentration was 0.50 m, big M, molarity. The question is, what is the new concentration? New concentration. We know that we diluted the solution, right? We took some amount, we added it, and we added water. So the new concentration should be less than the old concentration. But exactly what is the new concentration? Well, here I'm going to show you 2 ways to do this. Here's the easy way. We use the formula. Let's use a different color. We use a formula M1V1 is equal to M2V2, where the subscripts 1 refer to the situation for the first vial, and the subscripts 2 refer to the state of this in the second vial. M1 is the molarity of the first vial, and M2 is the molarity in the second vial that you need to find. V1 will be the volume that you took from the first vial, and V2 will be the total volume from the second vial. So let's plug those in. So we know that M1, the initial concentration was 0.50 m. The volume that you took was 2.5 milliliters, 2.5 milliliters. And that should be equal to M2, which is the new concentration that we're trying to find, times the volume, the total volume of the solution that's in the second vial. In this case, it's 10.0 milliliter. So if you solve for M2, you divide both sides by 10.0 mils, which means that the milliliter cancel out. You get 0.125 big M, right? to 2 sig figs, this is just 0.13 molars, big M. And there it is. You found the concentration in the second vial. And just to verify that it's correct, 0.13 is less than 0.5, so you found the concentration of the second vial. Now, I said there are two ways to do this. This is the first and easy way. We use the equation m1v1 is equal to m2v2. Let's write that again. m1v1 is equal to m2v2. So if you know any three of these, you can find the fourth variable. Why does this equation work? Well, this equation is just a way of keeping track of how much solute you move from one container to the other. So let's look at M1V1. M1 is measured in moles per liter, and V1 in this case we measured in milliliters. These units don't exactly cancel out, but we know if we multiply it by or divide it by a factor of 1,000, right? 1,000 mil is 1 liter. What we're really calculating on each side of this equation is number of moles. So what we're saying is if we have the first solution and we take an amount, we're calculating the number of moles in this small amount. And then we're moving it into a second vial, right? The same number of moles. And then we're solute, but then we're diluting it. Now in this second vial, the number of moles doesn't change. The only thing we've added is water to dilute it. So what we're saying in this equation is the number of moles that we took from the first container should be the same as the number of moles we have in the second container. And this is why this equation works. The only thing is we're playing around a little bit with the units because our volume is in milliliters in this example, whereas concentration is moles per liter. But in this example, it works out fine because the units cancel out. And that's all you should need to know to calculate to make dilution calculations. If you have any questions, you can reach out to your instructors, and I'm sure we'll be able to help you. I'll see you in the next video. Bye.